Welcome to 2.5. We are going to be talking about systems of inequalities. So we're going to look at how we graph a system of inequalities and then how to figure out the solution of that system. So a linear inequality resembles a linear equation. So you're going to have two inequalities. They just have an inequality sign instead of an equal sign. Okay, if we see strictly less than or greater than, we used a dashed line to graph. And if we see less than or equal to, greater than or equal to, with that line underneath, then we're going to use a solid line to a solid line to graph. The solution of a linear inequality is the set of all points whose coordinates satisfy that inequality. So it's going to be a shaded region. It's going to be any point in that shaded region or on a solid line that borders the shaded region. So stick with me, and when we actually do an example, I think that will make more sense. So let's start with just one before we get into a system. How do we graph just this inequality? So first thing we're going to notice is that this is greater than, so that means we're going to use a dashed line to graph this. And then we're going to graph just like we practiced in Unit 1. So this tells me that I'm going to graph 0, -3, and that my slope is 2. So I'm going to go from there. So let's graph 0, -3. I'm going to go up 2 over 1. I'm going to do a couple points just because it will help me make my line. If you have a straight edge when you're doing this on paper, that might be easier. And so now I'm just going to connect these points, but again, I'm going to use a dashed line to do so. Once you have your line, you have to figure out where the solution is. So one thing that I always think about is we obviously can think about greater than or less than, so like above the line and below the line, but sometimes it's harder to tell which would fill that. So one way to think about it is to think about the point 0, 0. And if I plug in 0 for x and 0 for y, then that's going to give me 0 is greater than -3, which is true. And so I'm going to shade in the direction towards 0, 0, which in this case would be over here. And so again, that is greater than, so it is above the line, but if you're unsure, you can always do that test. You can always test a point to figure out which direction you're going to shade. So that is the graph of that inequality. And all the points within the green show solutions of that inequality. Okay, so let's do another one where we need to solve this in order to graph it. So again, the first thing we should notice here is I have less than or equal to, so I'm going to do a solid line. And then this equation is in standard form. So when you see that, it's oftentimes more easier to find the intercepts in order to graph. So again, just like we did in Unit 1, we're going to plug in 0 for y to find the x-intercept. So I get 2x equals 12, which means that x is 6. So I'm going to graph the point 6, 0. And then I can say 3y equals 12 if I make x 0. So y equals 4. So I'm graphing 0, 4. Okay, so I'm going to graph these points. And then when I connect them, this time I get to use a solid line because again, it's that less than or equal to. Okay, so my line should look something like that. And now again, I just have to figure out where the shaded region is. I think this one's a little bit easier to tell what would be less than this line and what would be greater than this line. Less than would go this way. But again, if you're unsure, you can always just check that point 0, 0. So if I plug in 0 for x and 0 for y, that gives me the the inequality 0 is less than or equal to 12, which is true. So we're going to shade everything lower than that line. And in this case, my solutions would also include any point on this line because it's a solid line. So it would be anything in the shaded region and any point along that line. All right, now here is an example of a system. So we have two lines that we're going to graph first, and then we're going to figure out where the solution is. So let's look at this top line here. I'll do this one in red. And again, this is standard form, so I'm going to just find the intercepts. So 3x equals 3, which gives me x equals -1. So I'm going to graph -1, 0, and then y equals 3. So I'm going to graph 0, 3. Okay, and this is strictly less than, so this is a dashed line. Let's see if I can get this. That's pretty good. And if I was going to shade that, it is less than, so I'm thinking I'm going to shade this way. But again, I can always double check. If I plug in 0, 0, 0 for x, 0 for y, that gives me 0 is less than 3. And so yes, that is a part of the solution set. So I'm going to just shade this way. I'm just going to leave these arrows because eventually, once we graph our second line, our solution is where these shaded regions would intersect. So it's going to be a little bit easier to read if I don't have all this shading all over the place. Okay, so second equation, also in standard form. Let's look at graphing that one. So I would get x is -1, y is -1, and this is a solid line because it is greater than or equal to. Okay, so I'm going to graph again -1, 0, 0, -1. There's my solid line. Not perfect, but it'll do. And then again, greater than, I'm thinking it's this way. It would be above that line, but let's double check. If I plug in 0, 0, 0 is greater than or equal to -1, so that's correct. Okay, so again, I just drew the arrows and I'm going to leave them as is because I need to figure out where both of these solution inequalities would be true. So it would be below this red line and above this blue line. So it would be this area here. And so again, any solution to this inequality would be anything on this blue line in the shaded area, but not on the red line because it is a dashed line because it's strictly less than. Okay, let's look at one more. This one has 3 inequalities. So we're going to graph all 3. I'll graph this first one in red. So again, if I'm looking at intercepts, that would be x equals 5, y equals 5. And that is a dashed line because it's x plus y is less than 5. Okay, and it is less than, so we're going to shade below that line. That would be the direction I'm shading. Second line, we'll graph in blue. And this is in y-intercept form, or sorry, slope-intercept form. So I know the y-intercept and the slope. So that means m is 2, and the y-intercept is 0, -2. So I'm going to graph that, and this is a solid line because y is less than or equal to 2x minus 2. So I graph 0, -2, and then I'm going to go up to over 1 from there. And this is a solid line, like we said. And it says y is less than. So again, I'm thinking we're going to graph below, which would be in this case, this way. If you want to double check, I plug in 0. that would give me 0 is less than or equal to -2, which is not true. So since 0, 0 is on this side of the line, I'm going to shade in the other direction to make it true. Okay, and then lastly, I'll graph this one in green. Y is greater than or equal to -4, so I'm just going to graph -4. This is a solid line, or sorry, a dashed line at y equals -4. And it's greater than that, so I'm going to shade above that line. So where do all three of these intersect? It's this area right in here. Okay, so anywhere in this yellow region would be a solution, or anywhere on this blue line from point to point where it intersects those other two lines. Okay, so that is graphing inequalities.